I'm Mikkel Wallentin from the University of Aarhus. He's an associate professor in semiotics, and he will give some comments to Julie's talk.
As I said, had this been my own talk, I would have given more or less an identical talk to the one that you just heard, but given that I'm now playing the role as sort of the opponent, then I have to come up with something that's fun to talk about, some sort of interesting conflict, I suppose. So why am I at all standing here? Well, the idea is that some years ago I was doing my neuroimaging research, and I tend to take a number of risks, I may say, in the way that I perform experiments, and therefore they often go wrong. Nothing comes out of them, and so in that sense I add to the publication bias in that I have nothing to publish. And then I thought to myself, well, I have to publish something. And then there was this paper, this article in a Danish newspaper about sex differences in the brain. And I read it and I got furious because I knew that most of what it says was wrong. So I wrote a letter to the newspaper and got published, and the journalist, who's a very smart person, wrote to me and said, well, I shouldn't take this criticism to her or to the newspaper, I should take it to the research field because she just interviewed some people. And I said, no, I don't have time for this. But then, as I said, all my other studies didn't amount to anything, so I ended up writing this just to have something to publish. So the conclusion of this paper is that so my main field is within language processing in the brain, and the main conclusion is that the differences are very small, if there are any differences. One of the fun facts that you may find in this paper that I took from Hyde and Lim, a paper from 1988, is that there is this confirmation bias. So studies where the first author is female is more likely to report a female language advantage than studies where the first author is a man. But if you take them together, the effect sizes are more or less zero. Right. So, but in order to have something to talk about, I thought, this may relate to some of the last things that Julie said, namely that the world is dynamic in essence, and what you may measure with cognitive or economic games and experiments may not really capture the full importance of something. So I'll cast out the hypothesis that even small differences may be very important, and they may have big effects, and I'll try to explain what I mean by that in a few moments. And then also the opposite, that you may observe big differences that may have small, if no, effect at all. Okay. So the idea behind essentialism, I suppose, is it's sort of the everyman's kind of statistics. So again, we tend to overinterpret our stereotypes, but it may be the case that we need these stereotypes because they actually, some of them at least, have some predictive power. Maybe also because we tend to conform with these stereotypes ourselves. So in the sense, they can become self-fulfilling prophecies. But the idea is that if a model has some predictive power, and you can of course phrase that in statistical terms, then we may actually hesitate in throwing it out. So just for the fun of it, I thought to myself, this is a workshop about when gender is measurable, and I thought to myself, is gender really measurable at all? And Julie said that nobody studies the obvious, but then I wanted to at least be sure that I had studied the obvious here. So I took my students, the same students that I have to go and teach here in less than an hour, and I gave them a test. Actually, it was an empathy test. That's one of those self-report measurements where you always find gender differences, and whether that has anything to do with real life or not, I'm not so sure, but females really tend to rate themselves as more empathic than males. That's just, I've measured it many times, and the effect sizes are quite big. I'll not go further into that, but during this, I asked participants to give their gender, of course. And so they were asked to attribute a gender to themselves, and in order not to be too deterministic, I added another category. So my idea was that I want to see whether participants actually know if they're male or female, and they were able to do this. In this study we had 12 female and 7 males. Nobody reported themselves as other. And so here's the crucial thing, they also had to take, in fact, the same test again, because we were also interested in test-retest reliability in this measure. And I can calm you with saying that everybody was able to attribute the gender to themselves the second time as well. So 100% test-retest reliability, and of course this is good because now we know that at least with this small sample, gender is measurable. Okay. So then on to the interesting part, perhaps. So the hypothesis that small differences may have big effects. And so I thought to myself, when I heard that Julie was going to talk about risk, I thought, well, are there any obvious effects that you could think of when it comes to risk? What is the ultimate risk? Well, that's the risk of dying, I suppose. And are there any sex or gender differences in death? Yes, indeed, there are, and they're quite large, in fact. So here's a histogram from. So let's just look at it. This is life expectancy at birth across 208 countries. So how long do you expect to live if you were born in 2013? And yeah, so I found these data on the net. You can find them as well. Population Reference Bureau. So I didn't correct for population sizes in this. You could argue that that should have been done, but the idea here is that these are then differences in number of years that a male can expect, a female can expect to live longer than a male. And as you see, the mean here is around 4 years, and there's almost no overlap with 0. So the mean difference is 4.7 years, standard deviation 2.3, and this can be translated into a Cohen's d of 2.3. So this is a huge effect. Of course, this is not at the individual level, as Julie talked about. This is at the individual country level. So this means that there are only 3 countries in the world where males live longer than females. So this is not a cultural thing. This is a universal finding that everywhere on this globe, males live shorter lives than females. And this may, I think, be relevant for differences in risky behavior, because there are, as I see it, there are of course, many ways in which you can interpret these findings, but one, I would say, tempting interpretation is that even though you only have a small difference in risk-taking, if it means that you get run over by a truck, or if it means that you do not stop smoking, then that will actually kill you in the long run. Right, so then I went to data from Denmark in order to get closer to the individual level and to see whether this is just something that happened to be the case in 2013. And as you can see, these are data from the Danish Statistical Bureau, Danmark Statistik. As you can see, these are years from 1989 up until now, and you can see that the pattern is also stable over time. So this is not just something that that happened last year. And then I went to the data from 2014 in order to see whether we could get closer to something that would speak to the individual level that Julie was talking about. So here we have the age at which people died in Denmark in 2014, and the blue curve here is the males, and the red curve here are the females. And there's a slightly strange thing here, but that's because in this data set you could only become 99 years old. So everybody that has died at an age above 99 is counted as having been 99 years old. So what you can see, of course, is that there's a large amount of overlap, but I would also say that that's, of course, something that we can discuss. What is a significant overlap? What is a significant difference? I would say that this difference here in the early ages and the difference over here in the later stages of life is a rather big proportion. And let me try to elaborate on that. So if we take the difference between these two graphs here, then what we get is the proportion of male deaths by age in 2004. So now we're getting towards whether we can actually predict the gender of somebody simply by knowing the age that they had when they died. And as you can see, so in order to interpret this, you have to remember, of course, that in the early years there are very, very small numbers of deaths. So this, of course, will also add some variance to the data. And as you can see, during childhood here, the charts is all over the place. So I decided not to really go further into that. But looking at adults' death, what can we say? So if we divide these data up into 10-year chunks, then what we can say is that if a person in Denmark in 2014 died at the age between 20 and 30 years of age, there would be 71% chance that this person was a male. And that's rather good predictive power, I would say. Of course, this is something that we can discuss again. But further on, it continues. When we look at the ages between 30 and 40, we still have a predictive power of 37%. And as we go towards the later stages here, then the predictive power actually remains fairly good, I would say. Even though, and here you have to remember that at these points there are many more people in this part of the diagram, and when you then enter the far right side here, you become very, very, very confident in the prediction again. So just as good as you were in the 20s. So if you weight this by the number of people who died at these particular ages, then across the lifespan from 20 years onwards, we can predict gender with 59% accuracy just by knowing what the age of that person was when he or she died. And this may be just because that I'm a male. I think that that's actually a big thing. And then, of course, we can argue what are the reasons for this. And one argument could be that it's a structural thing. Males are simply more fragile and all have some sort of shorter expiration date than females. And again, that would be an essentialist viewpoint, that there's something with in the structure of males. Or it could be a functional hypothesis, and this could, for example, be that males are less risk aversive than females. And you could also take another obvious fact, namely the gender distribution in our prisons, that could illustrate the same point, that perhaps there is something to the fact, to the hypothesis, not the fact, sorry, to the hypothesis that males may be more risk-seeking or less risk-averse than females, and that this has some, at least, even though it may only be a small effect when we measure it in cognitive experiments, it may actually have some large impact on society. So small differences grow on you. That's the conclusion that I will try to convince you about. So then turning it upside down, there may also be very big differences that have no effects. And this is a big mystery to me, and also something that I've spent a lot of time looking into. So here nowadays the brain is the model for everything. So we so basically we cannot explain everything without having some sort of reference to the brain. But the gender differences in the brain, at least when it comes to structure, they're enormous. So here we have a plot of brain volume across the life of the early lifespan of humans. It's made on the basis of 400 participants. Some of them were scanned up to 6 times, I think. So in total there were 800 MR scans, and the total brain volume was then calculated, and the MR was fitted. And one of the interesting things is, that you can see that on average males have a deciliter more brain than females. And immediately you may think that must be important somehow, but when you then look at this plot, you also see that actually already from around 10 to 11 years of age, the brain size actually starts to diminish. And it happens a bit later with males, but the same is true. And across the lifespan, we lose around, again, 10% of our brain. So this is just volume, of course, of the total gray matter. You could also look of the total brain. You could also look at the gray matter to see whether this may just be because there's more white matter or more CSF, cerebral fluid in the brain. But when you look at the gray matter in isolation, you see the same pattern here. And also, when people actually start to count the number of neurons that males and females have in their brain, then you could argue that the cells are just more densely packed in the female brain. So we have the same number of neurons. It's just that the volume in which they are placed is bigger in males, but that's not the case either. So in 1997, Bette Parkenberg, and I can't remember his first name, Gundersen, did some calculations. They took out tissue slabs and started to count the actual number of neurons in these different small samples, and then they did an estimation of the total brain volume on the basis of that, on the basis of 100, I think, so samples, 100 participants. And they found that they estimated that the female brain has 19 billion neurons, and the male brain has 23 billion neurons. And then it's often said that, well, this has something to do with the overall greater body size, that you need more neurons to control the larger muscles, etc., etc. And that's to some extent true, but Parkenberg and Gundersen, they found a very poor correlation between height and weight and the number of neurons. So there's something about this that just isn't easily explained, but that we'll have to accept. And then I always have, when I present this, I always have Einstein on the picture, just to make sure that I mention that Einstein had a brain volume of at the size of an average female, just so that you know that you can be a genius and have a small brain. And so, but nevertheless, I've been interested in trying to find some sort of functional correlate of these structural differences. And for some reasons, I've been involved in a study of a particular syndrome called Klinefelter syndrome. So this is what I'll spend the last few minutes of my talk here talking about. Is I think for this symposium also a relevant study field, looking at global and regional brain differences between actually two cohorts of males. But why would that be interesting? Yes, that's interesting because Klinefelter syndrome is where the dichotomies, one of the places where the dichotomy breaks down. So Klinefelter syndrome is a genetic deficit, the most common in males, and basically what is wrong with them is that they have two X chromosomes and a Y chromosome. So they sort of gotten the best from all worlds you would imagine. Around 1 out of 660 males have this deficit. And as a phenotype, they look male, so that's why we call them male, I suppose. But they have one of the most predominant problems is that they have testicular atrophy, so they have small testes and they're infertile, and then they have some other characteristics that may speak to the stereotype of being somewhere between the male and the female phenotype. So I was lured into the study of this by the suggestion that they may have language deficit, and moreover that this may be somewhat specific to them. So, but as it turns out, this is not specific at all. So what we did was that we had a group of, oh, you can't see that. So the idea is that we had 66 Klinefelter syndrome and 65 Klinefelter syndrome and 65 controls, and they were matched for age and education. But as you will also see from this, they were not matched for anything else, more or less. They differ on a number of things. So personality, very, very different. Psychiatric symptoms, very, very different. Here we have some the autism quotient. They're also slightly autistic, so they're sort of they don't do so well in a number of issues. And then when we take sort of the overall picture, then we can also see that they have general cognitive problems. So their IQ is, at least in our study here, much lower than our controls. And this can be divided up into the verbal IQ, which is the parameter where they show the strongest deficit, compared to the performance IQ, where they're not so, where the effect is not so large. But here you see again Cohen's D values that I calculated yesterday of 1.3, and of course you can then argue back and forth whether that's a big effect or not. They have big difficulties in the educational system, so again this has some effect on them. But here's now the problem when you do neuroscience, and this is also a problem when you do gender studies, is that you have to, in this case, you have to have a control group for this particular comparison. And this can be either, as we did, a group of males that you then control for something that you think is worth controlling for, such as age and education. But we could also have control for all the other variables, and then we would have found no difference. We could also have used so what we did was that we controlled for this, but then our control sample is actually not representative of the population. So if you, in Denmark, so if you compare it to the general population of Denmark, the effects differences are even bigger. Yeah, so we chose this to match our patients on age and education, but now the control group is not representative. And you could also ask, why didn't we have a female control group? And I would say that basically this had to do with economy. Now, then we looked at the brains, and one thing that you can see here is that, again, this is total gray matter volume, and so there are two groups of Klinefelter syndrome. They're not so different, so we'll skip them. They're basically differing in whether they're treated with testosterone or not. So they have testosterone deficiency, and so some of them are treated with testosterone, but it doesn't seem to have big effects on what we measure. But we can see that there's a fairly large overall difference in gray matter between these two groups. And when we do what is called voxel-based morphometry and look in the brain to see where in the brain are these differences, we find that they're in these medial parts of the brain. And when we do a multivariate classification analysis, we can discriminate our patients from controls with almost 97% accuracy. So these have big effects. I've never seen so big effects in neuroscience. Yeah, but then the problem is that once we found this global difference that we also find between males and females, then if we want to compare at the local level, then that's no longer actually meaningful. Because you do a lot of nonlinear pre-processing of the data in order to make them comparable at the local level. So what we had to do was that we tried to remove the 10 biggest control brains and the 10 smallest Klinefelter syndrome brains to counter this, and then luckily we found exactly the same local differences. Because what we now of course have is a sample that is no longer representative of the Klinefelter sample, and the control is no longer representative of anything. So this was sort of a trick to counter the many problems that you have when you compare things that are not comparable. So, but here's then basically just the summary of what we did with all of those scores that you saw, where there were these great differences, big differences in terms of cognitive and differences and well-being and psychiatric symptoms and what have you. We had a truckload of data that we tried to compare with this gray matter volume measure. and we found 0. No correlation whatsoever. We tried within the control population, we tried within the Klinefelter syndrome sample, and we tried across it, and basically the only thing that predicts anything in the brain is the diagnose. So this, of course, is also something that you want to take with you when you look at all the in this case, structural analysis of gender differences in the brain, and you find that they've found some minute differences in somewhere in the brain that is a correlate of something. You should remember that when you have this huge difference at the macro scale, then you can in fact interpret those small scale differences, and they're usually also found with very small sample sizes. Yeah, so that's the take-home message. Small differences can have big effects, so we should worry about that, but big differences may also be non-important. Thank you.
Before we open up for I hope a lot of questions, would you like to respond?
Yeah, do you want me to use a mic or should I just? I'll just be brief, and I should comment, he had my PowerPoints, but not my work to go on. So I have to say that there was, I think, a little confusion about what I meant by individual differences. You said at one point that you were looking at individual differences when you looked at distributions, and that's what I was talking about as aggregate ones. And then in the conclusions about the life expectancy, you said males being, that was a statement about, the explanations could be about male risk aversion or other things. Those are essentializing statements that I would have liked to have seen talk about the averages rather than stated in that bold way about men. But we don't often hear it said that males are more criminal than females. I mean, you alluded to that with your prison population, but we don't usually say it that way. Because that would mean that every male in this room has some element of criminality, essentially in them that is absent from the women in this room. And that's not usually what we see when we look at statistics. The higher rates of death of men in their 20s is interesting. But to say that is some characteristic of males is kind of interesting because it's only the men in their 20s. Particularly things like reckless. If you put men in their 20s with other men in their 20s and give them a high-powered car or a gun, they tend to get in a lot of trouble. But that doesn't necessarily apply for men in their 20s alone and does not apply at all to men in their 40s or 50s. So to make the generic statement about men, this is what I was trying to say about GDI versus GDA is how you make that kind of statement. Is it a statistical statement or is it something that all men and all women carry around? The idea that small differences can have big effects, very true. I don't want to monopolize the discussion here. I could also go into some discussion about when small overlaps have big effects. So it's really a matter of figuring out what the size of these things are and what their consequences are. But I don't want to monopolize time because we've got a fairly short amount of time for everybody else.
Or perhaps you should come up here.
Yeah.
Okay.
You're the main speaker.
Bring it over all these cords without falling on my face.
Sorry. Again, your thoughts on the prevalence of men in pathological gambling with the references to the risk taking?
I think when you get into pathological cases and small number cases, it's interesting, again, to the aspect of prison population. Are we talking about something that is somehow an essential characteristic of men, or are we talking about something that applies to some particular population? I would say the same thing about men in their 20s in groups taking risks. Is that they like taking risks more, or do they just like speed more, power more, or the social context of being around other people who believe that men take risks these kinds of
So
things.
it could be a cultural thing, but it seems like there are more risk-taking, especially for that group.
Yeah, I mean, there's studies on reckless driving and these kinds of things. But for example, in the state that I live in, they have now something called a junior driver's license, which means that you cannot drive with anyone under age 18 in your car unless they're one of your siblings. And they find that this greatly reduces traffic accidents among very young drivers, partly because of distraction and also because of the showing off factor. That you don't have your buddies in the car with you, the temptation to go fast is not as big. So there are, social contexts in which these behaviors manifest more than others.
I was very happy for the example on life expectancy. Exactly. Since I think this brings us to a very huge question where we where we need to take the time to disentangle those things, since it is so obvious. Life expectancy, if we understand it as you put it, it is real, it is there, it is evident. We could have taken any other or we could have taken many other examples, like for instance, who does care jobs, and we put it that way. We will know they are females. Most, if we ask the gender question afterwards, we will have an evident answer to those questions, saying they are female who are doing those jobs. Who are people who are very well-known politicians? We will know these are men. There are so many examples. Still, I think this is so tricky because it's not what you were talking about. I think it's a question of who does what and who are which way. And this question of being or being and doing is a very tricky one that interacts so deeply with the way we do experiments, the way we do statistics, and the way we do also scientific work. And I think this is what we have to maybe you both can dispute or discuss about this question. What we start with something that is maybe this is also the point when you show this slide, the one the star slide and the other figure, and if you start by something and then we try to gender this thing, then we will find a gender for almost everything. But if we put it the other way, we have a gender and we try to make out something they have to do. This is not that easy. But our notions are so gendered, then we will find at the end that these are interacting very closely with what we do in science and in life. So I know I'm not very clear, but I think this is but I think it's a point really, because it becomes so evident that everyone has to say, yeah, it's more different, it's so huge. But I really think it's not, because otherwise I cannot put you both comment or the way you do science together. This is contradictory.
I'm not quite sure I understand the question. I mean, I have the life expectancy data there is what, I have no trouble with that. That is actual data. It shows distributions. It's gender differences in aggregate. The mean life expectancy is different. It's, what was the, what the d-value is on the life expectancy? Did you compute that one? That one looks like it's probably a 2 or something like that.
Across countries, it was 2.3, I think it was.
2.3. So that's a fairly sizable. Although again, it's not binary. It isn't that all women live longer than all men. Obviously, it's a distributional overlap. My point was that we tend to, if we're not careful, especially, and not so much on physical things like height. We can observe, but socio-behavioral characteristics, cognitive characteristics, this kind of things, math skill, language skill, that kind of thing, people very easily fall into this binary of, oh, you're a woman, you must be good at language. Oh, you're a male or you're an Asian, you must be good at math. These are become very common in popular work. And also, in some of these cases I've looked at in economics, seem to be deeply infiltrating the thinking of the economists themselves. Because they could not possibly say their results came from their data. Their results had to come from somewhere else. And a pre-existing belief in a gender binary is a pretty good guess. So I don't think there's a contradiction looking at data that shows differences.
You don't see any contradiction.
I disagreed with the way he stated the results because he was taking gender differences in the aggregate and stating them in bald statements about male risk aversion. And that's where I would disagree, is in the communication of that. But data on life expectancies, yeah, there's differences. And there's differences in the coming out of some of these studies of risk aversion. But is it this kind of difference or is it this kind of difference? And it's important to know. That's the point I was making. Did you have anything you wanted to?
No, I agree with you. So I suppose what I tried to say when I talked about essentialism is that perhaps we humans are fairly bad statisticians usually. So we have our essentialist ideas, perhaps due to some statistical property that we then overinterpret, and that and so that's one thing. And of course, in normal everyday life, sometimes that's a good thing that we can be very efficient in the way that we go about processing our environment, in that we have these stereotypes that enable us to be very efficient, but of course often we'll be wrong on the individual level if we have predispositions. And then, well, so now I lost.
Well, let me actually go back to the example I was thinking about how small overlaps can make a big difference, to kind of take the other side of this, which I think is still complementary to this whole discussion. But I gave you those two pictures of the categorical difference and then the overlapping difference. Think about what the distribution would look like for this variable, and tell me whether it's categorical or overlapping. Number of lifetime pregnancies. Categorical or overlapping? What do you think?
It's categorical.
Categorical, I'm hearing. Number of lifetime pregnancies. Overlapping or categorical, men and women? Overlapping. I'm starting to hear overlapping now. Why is it overlapping?
Not all women.
Some women never get pregnant. Some women choose never to get pregnant. In the US, it's about 15% of women past about childbearing age have not have children. So I don't know whether they never got pregnant or not, but you get the idea. It is an overlapping distribution. Could this make a difference? Well, there's certain employment discrimination that comes about because, say, women shouldn't be handling chemicals that might interfere with reproduction. Does that apply to women who are never going to get pregnant? Think about number of future pregnancies. Is that a little overlap or a big overlap? I'm 58 years old. What's my number of future pregnancies? Okay, number of future pregnancies. So what about employment discrimination that women are going to get pregnant and leave? Okay, it's not there. So finding those, you answer just like the class that I always try this on. Always think it's categorical. It's not. You got to think about those overlaps, and they do have consequences, just as some of these differences can also have consequences.
Thank you very much. Mikkel needs to leave for his class, and we need to take a break. So thank you very much.